Today we're going to look at how to make a data set and put it into Excel, how to create a simple graph with it, how to get a function out of that, and how to avoid one strange thing that Excel does that sometimes causes errors for students. So when I first do this example, there's actually going to be an error that comes up, and that's on purpose, because it's likely how you're to do it initially, and I'll explain the somewhat weird way you have to get around it. But let's take a look at an example from this week's lab. So in this week's lab, you're going to make a measurement, well, two measurements. Those two measurements are going to be related to temperature. So you're going to have some expected temperatures, and then you're going to have some actual temperatures that you measure. So I'm going to create some labels. So this is what Excel should look like when you first open it. So I'm going to put labels at the top of my data to help keep it clear. So I'm going to have expected temperature. That's going to be what I expect it to be based on some calculations I do. And then I'm going to tab over. If I press tab, it will move one over. And I'm going to put up measured temperatures. Now, I can't see everything, so I'm going to, if you go up to the top here, you'll notice that the shape of the cursor switches into this line with two arrows on either side. If you click on that, you can then adjust your column, and I'm going to do that to open it up and make it the size for these things so that the names fit. Now, your expected temperatures may not be exactly what mine are. There is a calculation you have to do, for example, for the boiling temperature. So let's say that I expected my temperature to be 0, and the other expected temperature based on my calculations was 99.85, or 99.9, let's say. Note that yours might be different than that. It's based on your barometric pressure, so don't just copy my 99.9. Calculate it using your barometric pressure. Now, that's what you expect the freezing and boiling points of your water to be, let's say. Then you make some measurements in class. So those are going to be the things your thermometer tells you. So my thermometer tells me that when I put it in the ice, that it's actually 1.5 degrees, it thinks. And then let's say it said my boiling temperature was 98.5. You may get different things. This is just what I'm saying I work with my data. As an aside also, it's good to write a note here of what units you're in. So for example, both of these are in Celsius. And when you do Celsius, you have to backspace over because it makes a copyright symbol at first. Please stop. There we go. Yeah. I will manage this some. Okay, it stopped. Sorry about that. Side. So we have our units. Those are good to keep track of as well. So now I've got my 2 data points. In the future, you'll have more data points. You can type in more. And later in the semester, we'll work with huge lists, like hundreds, and then I'll show you how to import data then. But for now, we're just typing in the things we measured and the things we were expecting. So I want to graph this. So I'm going to go up to the top, and notice how my cursor changes from this cross shape to the downward arrow, and it highlights the tab like A is now green, whereas before it wasn't. So if I do that, and I click my left mouse button and hold it down, I can highlight that, and if I keep it held down, I can highlight B as well. Then I let go, and now I have all of A and B selected to make a graph, no matter how many things there are in that graph. It could be 2, 10, 100. Now, I want a set of points only because I want to draw a trend line through it so I can get an equation. So the idea is I'm going to have Excel tell me what does it think the best line is to go through these numbers. In this case, you only have 2 numbers, so it's going to be a perfect fit. But for future labs, when you have more than 2 numbers, it probably won't be a perfect fit. So Excel's going to do some math to figure out what is the best line that is the closest to matching all of the points, assuming they're linear. So we're going to go up to the top tabs and go to Insert. I'll also point out yours may look a tiny bit different depending on your exact version of Excel, but it should be something like this. Now, I'm going to go over to all these graph types, and I've got these types with these points if I go over here. And there are multiple options, and I'm going to choose the one that just makes dots. Now, when I do this, this graph is actually not a good graph, and I purposely did this to show you what ends up confusing the system. So, you'll notice I have 4 dots. That doesn't actually make sense, because my goal in this lab was I have an expected temperature, and I'm comparing it to a measured temperature. I should only have 2 dots. For whatever reason, sometimes when you make an Excel graph, having words in the first column point here, A1, confuses the program and makes it graph it strangely. I do not know the exact reason, but I know that it happens. If that happens, you can delete this, leave it blank. Now if I highlight it, and I go and I make a new graph, Lo and behold, it fixes it. I do not know the exact reason for this. I'll be honest, but that's how you fix it. So if you have that problem where you have way more dots than you should, that's one of the things that can cause that. So now that I have this graph, I need to do a few things. First, I want to label my axes. If you go here, you'll see this little green thing here. If you click on that, it'll let you add stuff, and I want to add axes titles. So when we're doing this, I want to add my labels. So my x-axis, that was my expected temperatures. So that was going to be expected temperatures, and they were in Celsius. Let's see. And I'm going to insert a symbol to insert the degree sign. So I've got degrees Celsius. So now I have that. And then I go to this other one, and I'm going to say it is measured temperatures. I put my degree sign in again, Celsius. So now I have my x and my y-axis labeled. I then need to come up with a title because measured temperatures isn't really a great title for this. Since it was a calibration graph, I'm going to call it a thermometer calibration graph. There is not one exact answer for what your title should be, but it should be descriptive of what is the goal of this graph, what is it showing, rather than just the label of one of your variables. So come up with something each time that describes what your graph is of. Now that we have this made, we have one more step. We need to get a trend line. So go to any of the points, it doesn't matter which one, and right click on it. You'll get some options here, and one of them is to add a trend line. That's one way to get this. The other is you can go up to the green marker here, and you can add a trend line that way. Both work. So I'm going to add my trend line, and it's going to give me some options. In this course, we're going to stick with linear trend lines. There are reasons why you could do a match for non-linear sets of data, but we're not going to work on those because we don't do enough to talk about why a certain trend would be better than another and how to tell if it's a good fit or not, or if it just happens to look nice but it's poor. So that's going to give me the line through it. Now, we also need to actually have the equation. So I'm going to go down here on my options, and there's a button that says Display Equation on Chart. And if I click that, it makes an equation for me. I'm also going to display the r-squared value on the chart. The important part about r-squared is that the closer it is to 1, the more linear your data is. So you may get something like 0.98 in future labs. This particular lab will always say 1 because you only have 2 points. And you can always draw a line directly through 2 points. But as you get more points, it may not always be perfectly linear. R-squared helps show that. So it helps me as the professor see how well did your data match up, and it can be helpful for you to figure out, is my data a good match, or do I need to make some adjustment, or do I need to not trust it that much? This equation right here, y equals, in my case, 0.971x plus 1.5, let me highlight it. That's the equation I'm going to use to calibrate my thermometer. So since x was my expected temperature, y was my measured temperature, I can plug in my measured temperature and solve for my expected temperature. Sorry, make sure I word that right. Yeah, you can plug in your measured temperature and then get what your expected temperature was, because this expected temperature you could also label as the actual temperature. So we're saying that your thermometer measured one thing, but you actually found something else. Note that I'm fine with actual or expected. These are both OK x-axis labels. They would both be true statements, just different ways to say it. But another way to think about it for you is that the x-axis here is going to be what was the real temperature our system was at, whereas the measured temperatures on the y-axis are what is my thermometer telling me it is. So you may have to make some adjustments, or maybe your thermometer is perfectly calibrated, and it'll come out exactly the same. You'll just use this equation by plugging in your measured temperature for the y, and then solve this equation for x. Now, one final step to help you with the lab is, let me open up, so I have a copy of the lab open right now, actually. So it mentions that you need to attach a copy of it to the back. You'll notice right here, prepare a calibration curve, observed temperature versus actual temperature. This should be attached to the back of the write-up. So what I'm going to do is I'm going to go and make a new page at the end where I can attach my graph. And what you can do is you go back to Excel, and I click on it, and I press Control-C, or Command-C, I think it is if you're on a Mac, but whatever it is that your copy function to copy it. You can also, I believe, right-click and press Copy. Then I'm going to go to my Word document, I'm going to go here, and I'm either going to press Control-V, or I'm going to right-click and press Paste. So if I press Control-V, I copied my graph. Okay, I have a weird setting to mine. What did it do? Let's see. I need to give it more space. I did something very strange. Of course, this error happened when I was trying to view it for you. I do not want to re-record this, so I'm going to try to figure it out very quickly. And if it can't... Oh. So I had a weird setting related to how my graph shows up that you probably don't. But if yours does what mine just did, where it suddenly disappears into the back, one possibility has to do with this setting right here. It's a layout option. And so what it does is it lets you decide how the graph is going to show up next to text. So I just chose this option where it's got some space around it and it'll let it move around however. You can also do stuff where you can do it behind text and other such things. Mine, this inline with text option, ended up having a weird thing with one of my page breaks. So if it's having a problem, you can try changing the setting to different options to see which one works well with it. So that should help fix it. You'll notice now I don't have to try to turn in the whole Excel table. I can just attach this graph and I'm good to go. So with that, I hope that helps with trying to plot your data and get it attached as a graph to the back of your lab report.